Okay, in this video we're going to talk about abstract inequalities. And it's exactly what it says on the tin. The material we're covering here is very different. It is quite obscure. And in basically every question, we're going to have to prove that things are positive. So before I show you a question, I just want to show you some of the theory that's really, really important. If you take any real number and you multiply it by itself, it will always be greater than or equal to 0. If I take 5 and multiply it by itself, I get 25. If I take minus 5 and multiply it by itself, I also get 25. A minus by minus gives me plus, a plus by plus gives me a plus. So if you square a real number, it will always be greater than or equal to 0. The reason I have the equal to in there is because 0 is a real number and 0 squared is 0. Now, in these questions, just a mistake a lot of students often make is they say that anything squared is greater than or equal to 0. You are not allowed to say that, because in Leaving Cert Higher Level Maths, you might have already come across it, but we study complex numbers. And sometimes when you square a complex number, you could get a negative value. So just be aware, you are not allowed to say in any of these questions that anything squared is greater than or equal to 0. The last line of every single abstract inequality is going to be that any real number squared is greater than or equal to 0. That's our justification. So for example, if I know that a and b are real, imagine if I had a plus b to be squared. I can easily say that a plus b to be squared is greater than or equal to 0. If a is a real number and b is a real number, and I square it, no matter what a and b are, if I multiply it by itself, it's going to be positive, it's going to be greater than or equal to 0. But what I need you to recognize is what you get if you multiply a plus b by a plus b. A plus b to be squared, if you multiply it out, is a squared plus 2ab plus b squared. You need to recognize that. In these questions, you're going to get to this line. You're going to manipulate a question around and you're going to get to a squared plus 2ab plus b squared. And you need to be able to go straight from this line to this line. A squared plus 2ab plus b squared is a plus b to be squared. Because if you multiply out a plus b, you simply get this. So you need to be aware that a squared plus 2ab plus b squared gives you this. Likewise, if I have a minus b to be squared, a minus b multiplied by itself has to be positive. As long as a and b are real numbers, if I multiply it by itself, it's definitely positive. If I multiply a minus b by a minus b, I get a squared minus 2ab plus b squared. In a number of the questions we do in this video, you're going to get this line. And when you get this line, you need to be able to go straight to this line and say that a minus b, that this is the same as a minus b to be squared. That's just some of the learning work. I always tell students to learn that. You should know exactly when you see this that you can convert it to that. When you see this, you can convert it to that. Obviously, it's not always going to be a and b. It might be p squared plus 2pq plus q squared. Obviously, I don't have to use the same letters, but if they're in this form, then you can go straight from there to there. Let me show you an example of the type of questions I'm talking about in this video. Okay, the type of question you're going to get based on this material is you could be asked to prove that a plus b is greater than or equal to 2 root ab. And they'll tell you that a and b are elements of OR. We're talking about real numbers in these questions. Now, if you don't know what the value of a is and you don't know what the value of b is, it is impossible to prove that a plus b, you'll never prove a plus b is bigger than a by b or anything like that. It just can't be done. What we need to do is we need to move everything to one side of the equation and prove that the whole thing is greater than or equal to 0. If I can get it all to be squared, it's greater than or equal to 0. You'll notice that in every single question in your abstract inequalities, that will eventually be your goal. Move everything to one side and then just get it all to be squared. However, in this case, there's a complication before you move things across. I need to first try and eliminate my surd. My advice to you when you see these questions is identify the immediate complication, eliminate it, and then move everything to one side. I've identified here that the immediate complication is the square root. And in order to eliminate the square root, I need to square it. So I want to square this side to eliminate the surd. And if I square this side, I also need to square this side. So if I square the left-hand side, it'll become a plus b to be squared. And it's greater than or equal to 2 to be squared will be 4. And root AB multiplied by root AB simply gives me AB. Now, if I multiply a plus b by a plus b, I would get a squared plus 2ab plus b squared, which is greater than or equal to 4ab. Once again, if you don't know the value of a and you don't know the value of b, you're never going to be able to prove that this is bigger than this. It can't be done. Now there's no immediate complications. Now you move everything to one side of the equation. Clearly in this case, I want to subtract 4ab from both sides so that I get a 0 on the right hand side. I would get a squared plus 2ab, but then this would come across and become minus 4ab plus b squared. You'll notice the way I've written this, the two middle terms, they're like terms. So this would become a squared minus 2ab plus b squared is greater than or equal to 0. Now, the last 2 or 3 lines in these questions is nearly always identical. You should notice this from what we're just after looking at. You need to know off the top of your head that a squared minus 2ab plus b squared can be rewritten as a minus b all to be squared. And I am happy out with this. I've a 0 on one side and everything on the other side is squared. If a and b are real numbers, I know that any real number to be squared is greater than or equal to 0. So I know for a fact that this is true. I can just tick that and say that it's true. But again, you have to justify it. And my justification is that any real number to be squared is greater than or equal to 0. You cannot say that anything squared is greater than or equal to 0 because that's not true for complex numbers. You could square a complex number and get something negative. That's not going to come into play in these questions, but in order for your justification to make sense, you have to say that this is definitely greater than or equal to 0 because any real number to be squared is always greater than or equal to 0. So the general template in these questions will be eliminate your complication and then move everything to one side, and it will usually look, the last couple of lines will usually look more or less the same as this. If we have a look at this one, often it's not going to be obvious what to do straight away. Often you're going to have to play around and try one thing, and if that doesn't work, you try something else. There are a number of ways of carrying out this question. Ultimately, I need to end up with the whole lot on one side, and I'm going to have like a plus b to be squared or else a minus b to be squared. The ending of these questions is very predictable, but the start is a little bit different. These are essentially a good way of getting you to practice factorising. You should recognise now that you can factorise the left-hand side and you can factorise the right-hand side. I know that if I factorise the sum of two cubes, a cubed plus b cubed will give me a plus b times a squared minus ab plus b squared. That's one of the very first things that we looked at in algebra. On the right hand side I can also factorise. On the right hand side I can simply factorise out what's common. The thing that is common to both of these terms, well, both of them have an a to the power of 1 and both of them have a b to the power of 1. I can factorise ab out of each of these terms. The first term here is a squared b. So b divides into the b and it cancels. A divides into a squared and I'm left with 1a. Now if I divide ab into ab squared, the a divides into the a, the b divides into the b squared, and I'm left with just plus b. If you're not 100% on that, just think about what would happen if we multiplied it out. ab by a would give me a squared b, ab by b would give me ab squared. You should notice now that in each case I have an a plus b times this and I have a plus b times this. So I can divide both sides by a plus b, and essentially the a plus b's cancel each other out. Now I have a squared minus ab plus b squared is greater than or equal to ab. So at the moment I have an a squared minus ab on the left. I'm going to subtract ab from both sides, and I also have a b squared. That leaves me with nothing left on the right hand side, so I can just say that it's greater than or equal to 0. The only way I can prove something is greater than or equal to 0 is if I've got the whole thing to be squared. But luckily, this one is working out nice enough. The two middle terms are minus 1ab minus 1ab, which gives me minus 2ab plus b squared. You'll notice I have exactly the same as what I had in example 1. You need to recognise that a squared minus 2ab plus b squared is the same thing as a minus b to be squared. And I know that that one is true. The reason I know that is true is because I know that any real number to be squared will always be greater than or equal to 0. So hopefully you'll recognize a few similarities between example 1 and example 2. The first few lines are the only things that are going to vary in these questions, and then when you get down here, it'll all become very familiar. So I'm going to give you 2 questions now that I want you to try, and they're going to be very similar to these two. Okay, so I want you to practice 2 questions here. First one, I'm using the letters P and Q rather than A and B, but it's the same principle. I want you to prove that P plus Q times 1 over P plus 1 over Q is greater than or equal to 4. And I'm telling you that P and Q are elements of or in other words, they're real numbers. So again, I want you to play around with that, see if you can figure it out. The second question, I want you to prove that A over B squared plus B over A squared is greater than or equal to 1 over A plus 1 over B. And again, A and B are elements of OR. So I want you to pause the video now and try and prove both of these and then compare them to my solutions. Okay, so there are a number of different ways of doing this one. What I've opted to do here is to simply multiply out my brackets and see what happens. So I need to multiply P by the second bracket and then Q by the second bracket. P by 1 over P is simply P over P, which works out as 1. P by 1 over Q is P over Q, which I can't simplify for the moment. Then Q times 1 over P is simply Q over P, which again I can't simplify yet. But Q times 1 over Q is Q over Q, which is actually 1. So in this case I added the 1 and the 1 and I got 2. I have 2 plus P over Q plus Q over P is greater than or equal to 4. What I've done in the last line is I've subtracted 2 from both sides. Since I'm running out of space, I'm going to start this from up here and we'll see what to do from there. So all I've done really is multiplied out my brackets. And now I'm looking at this and I realise that my immediate complication is the presence of the fractions. So in order to eliminate the fractions, I have to figure out what can I multiply everything by here so the fractions will be eliminated. So what will both Q and P and 1 divide into? The thing they're all going to divide into is P times Q. What I need to do is multiply the entire equation by PQ. Let's have a think about that. If I multiply P over Q by PQ, you need to view this as the Q on the bottom will divide into the Q on the top. So I'll actually just end up with a P. So it's P times whatever was on top of the fraction, which is P, so it's P squared. If you're struggling with that, we might write it over here. This I have P over Q here, and I'm multiplying by PQ over 1. So the Q on the bottom divides into the Q on the top, and I have P times P, which is P squared. I have to do the exact same thing here. Here I have Q over P, and I'm going to multiply that by PQ. If I multiply Q over P by PQ, the P on the bottom divides into the P on the top, and I'm left with Q times Q, which is obviously just Q squared. And then on the right hand side I just have a 2, so if I multiply 2 by PQ, it's simply 2PQ. And at this stage now we're in good shape because hopefully you'll recognise this. Now I'm ready to move everything to one side and prove it's greater than or equal to 0. If I subtract 2PQ from both sides, I get P squared minus 2PQ plus Q squared is greater than or equal to 0. You should recognise this as simply A squared minus 2AB plus B squared. Just instead of an A I have a P, instead of a B I have a Q. I recognise this as P minus Q to be squared. And now I'm happy out. The whole thing is to the power of 2. And I know that that one is true. The reason that that is true is because I know that any real number, if I multiply it by itself, is going to be positive. Any real number to be squared is greater than or equal to 0. So that's it. I get full marks for question 1 if I do that. Okay, question 2, we were asked to prove that A over B squared plus B over A squared is greater than or equal to 1 over A plus 1 over B. Once again, there's a couple of different ways of doing this one. So if you don't follow the same method as me, then that's fine. The way that I would do this one is I would get a common denominator for the left hand side and a common denominator for the right hand side. In order to get a common denominator for the left hand side, it would simply be the two denominators multiplied by each other. I could say the common denominator is A squared multiplied by B squared. And then I would have to ask myself, how many times does the bottom of the first fraction divide into my common denominator? B squared divided into a squared b squared. Well, the b squared would cancel out with itself and I would be left with a squared. So it's going to be a squared multiplied by whatever's on top of the fraction, which happens to also be an a. Then there's clearly a plus in between them, and I would ask myself, how many times does a squared divide into the common denominator? A squared would divide into itself and I'd simply be left with b squared. So it's b squared multiplied by whatever's on the top of the fraction, which is also a b. I'm going to do something similar on the right hand side. On the right hand side I'm going to get a common denominator by multiplying the denominators by each other, a multiplied by b. I'd ask myself, how many times does a divide into this? A divided into this goes b times. So it would be b times 1, which is on the top of the fraction. Then there's clearly a plus in between them, and I would divide b into the common denominator. B divided into AB is going to go a times. So it's a times the top of the fraction, which is a 1. And at this stage, I want to eliminate my fractions. In order to eliminate my fractions, what I need to do now is multiply everything by a squared b squared. If I multiply everything by a squared b squared, that will eliminate my fractions. I know that because this denominator will divide into this, and AB will also divide into this. Because both of my denominators divide into this, that will allow me to eliminate my fraction. A squared b squared divided into a squared b squared goes once, which means if I multiply this fraction by a squared b squared, the bottom is simply eliminated. And a squared by a is a cubed, b squared by b is b cubed. The bottom of the fraction would be eliminated. On the right hand side it's a little bit trickier. AB divides into a squared b squared ab times. What we might do is write this one out because it's a bit trickier. I have b plus a over ab, and I'm multiplying that by a squared b squared over 1. This a will divide into one of the a's on the top. This b will divide into one of the b's on the top. So essentially I'm left with a times b. So essentially I'm going to be multiplying ab by what was already on the top. What was already on the top of the fraction was a plus b. And I'm just multiplying that by ab. This is progress because I've eliminated my fractions. Now there's nothing I can really do with the right hand side, but I do recognise that on the left hand side I have the sum of two cubes. I can factorise the sum of two cubes. I know that a cubed b cubed is the same as a plus b times a squared minus ab plus b squared. And the right hand side I'll leave it exactly as it is for the moment. Hopefully you'll recognise this from something we did in example 2. What I want to do next is I want to divide both sides by a plus b, or in other words just cancel them out. So now I just have a squared minus ab plus b squared is greater than or equal to ab. So I'm going to subtract ab from both sides so that I get a squared minus ab plus b squared is greater than or equal to 0. Now I'm happy out because my two middle terms are like terms. I can write that as a squared minus 2ab plus b squared is greater than or equal to 0. And hopefully once again you'll recognise this is the same as nearly all the other questions we've done. We end up with a minus b to be squared. And I'm happy out with that. I know it's true. The entire left hand side is to be squared, so I can conclude that any real number to be squared is greater than or equal to 0. And that will give me full marks. So those abstract inequalities are very, very, very obscure, but I think it's important you recognise the last few lines are always the same. There's no one size fits all for the first few lines, and I think in an exam you might try one thing and if it doesn't work you try something else. You don't necessarily have to follow the steps that I was doing, but it does need to be similar.